Hello, it's Sabrina here, and welcome back to continue our learning journey. And today I'm sharing the screen of my Flutter channel. As you can see, we get 9 subscribers, and I'm already very, very happy. And I want to say a big thank you for whoever subscribed. I don't aim to be famous, popular in this channel, but I enjoy what I'm doing. So if you are new to Flutter, I actually have very good video description. This is from yesterday, and add localization. If you go down and for more, and head over to Flutter Dev, you can read all the official documentation, and I think I should show you this in the video. So, oh, by the way, before we go there, let me show you the channel, the playlist. So we are in here. So we are on Study With Me for complete Flutter course, where I'm posting a full learning journey with this GitHub repo, which is his course, not mine. And I made it very clear. But the code is public, where anyone you can copy and fork, and then you follow the instruction, and you can check out to each branch to follow along with the module. And I name my video with this course module 6. It's the module similar as he mentioned, section A, section 3. And here you can see on the screen, this is the course that we are learning. And and you see the module 4 is what we are going to do today. And yesterday we finished until module 3 part 2. Yeah. Oh, module 3 part 1, and there should be another one, module 3 part 2. Maybe I didn't upload. And I have a brief introduction about what this video is about. And each video is quite long because we are coding and learning. And in the future, as I mentioned in the channel description, I plan to add more interesting video, and I have a lot of plans for other tutorial. Not this one. There's a lot of a code lab tutorial that I plan to do together, so these games and build app, especially with AI. I remember I saw some interesting tutorial using the Gemini and Flutter. And after all this, I indeed plan to start to build new apps myself. I built app before, and I've been working for company to build app for other company. But I want to continue learning more, and then create different type of app using the AI or maybe the Flutter Flame, the game. Yeah, and another, again, with 9 subscriber, over 11 video, I'm already very, very happy, because this kind of coding tutorial video, I don't expect a lot of view, right? And it's you can easily get a view posting some silly shorts video, but that's not my goal. My goal is to keep learning, and I aim to continue every day or at least if I get busy, then at least every week. So let's continue. And today is Sunday here in British Columbia, Canada. Let's code. Okay. So after you fork the GitHub, and you should check out to a section 4. That's what we are going to do today. We are going to apply Riverpod and use this to for our state management. And again, this is actually the for Flutter itself, it's a beginner level. For if you are completely new to coding, this is slightly more advanced. Okay.
Welcome to this section where we will learn how to use Riverpod, which is a powerful package that helps us with state management and much more in Flutter. And let me just say that this is one of the core sections of the entire course that will build upon what we have learned about app architecture, and we will really start to get a good understanding of how things fit together. So this is what we will cover. We will start off with an introduction to Riverpod so that we can get a good feel for what problems it helps us solve. Then we'll install it and set it up in our project. And we will start simple by using it as a dependency injection system so that we can declare providers that we can use to access the repositories inside our widgets. And as part of this, we will learn about ConsumerWidget as well as the concept of ref, which is an object that we can use to access all our providers. Then we will focus on how to read asynchronous data and learn how to work with StreamProvider and AsyncValue as an alternative to StreamBuilder and AsyncSnapshot.
It's mostly just some slides.
AsyncValue helps us reduce boilerplate code when mapping different data, loading and error states to the UI. We'll then learn about two very important modifiers known as family and autoDispose, which are essential in a number of different scenarios. And we'll wrap up by creating a reusable widget class that builds on top of AsyncValue and helps us reduce boilerplate code. And if I had to summarize all these points in one sentence, I would say that this section is about understanding how data flows from the repositories and into our widgets, and how Riverpod helps us connect everything together while also giving us APIs for disposing things properly.
It's pointing about this part. So from presentation layer, writes all the way to the data, and data will go up. It's like a flow of data. So you are not missing anything. The video is, there isn't much code. When you see code, you can see me coding, and it's the same as him, and he gets talking about all the slides.
So if you've never used Riverpod before, I recommend that you follow all the lessons closely, because in the coming sections we will build upon what we learned here. On the other hand, if you're already familiar with Riverpod, you can probably speed through the first few lessons, though I still recommend that you follow the lessons about async data and modifiers more closely. And by the end of this section, we'll have covered many essential Riverpod APIs, and we'll understand how to use it to read data going from the repositories and all the way into our widgets, focusing on the functionality to show product listings and product page details. But of course, reading data is only half of the story, and we'll also need to figure out how to respond to user events and write data by going in the opposite direction across all these layers. And to do this, we'll need to cover some additional concepts that go beyond the basics. And we'll explore all of this in the next section by implementing user authentication, so that we can understand the entire flow for signing in and signing out of the app. And as we go through these two sections, we'll cover most of the things that you need to work effectively with the Riverpod package. But of course, we have an entire e-commerce app to build, and in addition to product listings and authentication, we'll also cover other interesting features such as shopping cart, checkout flows, orders management, reviews, as well as many others. And before we even get to those features, I think it's really important that we talk about testing, because testing has an influence on many design decisions that we make with our code. So before we move on to all the remaining features, I'll include an extensive section about automated testing, so that we can really understand how to test all these layers individually and as a whole. So as you can see, we have a lot of ground to cover, and I hope that you're excited about this. And as we go through some of this material, I recommend that you keep the official Riverpod docs handy, which you can find at riverpod.dev. And you can also use my ultimate guide to Riverpod as a reference, as this is a long article that covers most of the Riverpod APIs in logical order. And make sure that you also check the notes below, where you can find all my Riverpod articles, covering the latest changes, as well as the Riverpod generator and Riverpod linked packages, which were added alongside the Riverpod 2.0 release. So let's continue on the next lesson, where I'll give you an introduction to Riverpod.
That's great. I used the Riverpod before, then was like 3 years ago, and I know they changed a lot. So for me, it's new, and I forgot many things I learned. So let's continue.
Welcome to this introduction to the Riverpod package. And as you may know, Riverpod is described as a state management library for Flutter. And when it comes to Flutter, there are a ton of ways to manage state. And if you really want, you can go quite far with the state management APIs that Flutter offers out of the box. And these include stateful widget and set state, inherited widget, and useful classes such as change notifier and value notifier, along with reactive widgets such as value listenable builder and animated builder. And while I'm not going to discuss these in detail here, you should have at least a basic understanding of how they work. And if you want to explore this in more detail, I've included a good overview of all these APIs in this article, which include
auto-generate, So for introduction to Riverpod, yeah, this is the video, and he mentioned another article about Flutter state management, warning against 𝒂𝒑𝒑𝒂𝒂𝒂𝒂𝒂𝒂𝒂, yes. Used for resources. We can read, but Riverpod is very powerful solution, multi-purpose, DI state management data caching, reactive caching, great. This guy is very, very good. So and you can go to this link and do the reading. It's a little bit older one, so he talked, I think I read before, this is a long time ago. Yeah, local versus global state and inherited state. It's based on this huge widget tree, and so if you have a widget, for example, a child of this very right side of the green one, and then you put a provider somewhere, say in the middle of the green one, you will get error. It's not the child of the other provider. So using the inherited widget and provider, you need to be really careful about the widget tree. Value notifier, check notifier, yeah. It's easy to get confused with all these. I think the main point is not to memorize what's this about. It's more about what problem are they solving. So these are only one of the way to manage the state, right? FutureProvider and StreamProvider. There's a lot of boiled code with these, but this is Flutter default way reading the data that's coming from a future or a stream. You see, it's really long, and in a more functional programming style, it's a lot shorter. You see, different situation, unloading on data, on error, and what do you render. It's a cleaner way. And see, there isn't a lot. So here, this is a newer one, Flutter Riverpod 2.0. He has a new updated one. It's similar. Okay, oh, this is long, you see. If your application already use Flutter hooks, you can install hook Riverpod. I'm not sure if we are using hooks. So the provider scope you put into the very top of your app. The widget then stores the state of all the provider we create. Under the hood, provider scope creates provider container instance. Most of the time you won't need to care about this. Register a listener during the app startup. It's going to be a lot, but we want to know why. So why do I need to register a listener as soon as the app starts? Listening to the incoming messages, incoming dynamic auth state changes. It's a similar like yesterday's video I showed you in my company, where we have a lot of observe state functions and we are calling at the app start in the main.dart. So it will start fetching the data and start the stream listener. Normal initialization, you do this. An option, register listener, you can listen here. Let's finish one by one. Again, you can skip this session. We will go through quickly and then continue the lesson. I don't want just to listen to the video, right? And we listen. The video, it doesn't have much a lot on reading and coding. So create reading a provider. This is how you do. Provider with a string value. Ref, the declaration, the provider, a function. Using ConsumerWidget, extend consumer. So you have a provider like this. I think it took me a long time to understand why we are doing so. Because I was saying, I was thinking like, all you need is just a string. Why don't you just create final string hello world? And you just put a string here. Why you were this way? And you can make the string value as a global. Any class can read it. But later I understand. So the examples are not very good. So in reality, you don't do this, right? You get a data from somewhere else, and it's not going to be a string. I mean, like a const string. It's gonna be a dynamic data using the consumer. This is the consumer with the builder. It's very similar with the stream or future builder kind of syntax. You have a builder and you return a widget where this will the read dot watch this string, and this string will will change. It can be changed in different widget tree. For example, a user input. If you want to catch what user enter some question on yes or no, and on the other side of the app, you want to get the data. So that's a way, and the change is simultaneously because we are listening to the change. Ref option is one of the consumer's builder argument, and we can into work. So when should we use a consumer over a consumer widget? Oh yes, you can use consumer widget. I already know. So do you know? Add a consumer. So consumer is very handy if you only have a small data on the very bottom of the widget tree. You use consumer, but if you want your whole widget, whole class to listen for the changes, you do the consumer widget. Consumer stateful widget. But what if we have, yes, if you have a stateful widget, you use stateful widget, then you can access the init state. By the way, when I first started Flutter, people were saying the stateful widget we should avoid and make our widget and to stateless widget as much as possible. But that's not true. There isn't much performance issue with the stateful widget. It gets more boiler code, and actually I think in one of the article I saw where people discuss about cutting the stateful boilerplate with the new macro, and it's a very interesting one. Okay. So it's the same. What is widget ref? Widget ref? Ref is here. Yeah, if you wonder where the ref come from, suddenly you can access the ref. It's from this class. Subclassing from widget stateful widget. And then you need to understand what's difference on ref.read and ref.watch. If you use hooks, as we have seen, we can watch a provider's value by using the ref object widget ref, yes, as argument. Note there are some similarity between build context and widget ref. Build context lets us to access ancestor. For example, the C medium query. Widget ref lets us access any provider inside our app. In other words, widget ref lets us to access any provider in our code base as long as we import the corresponding. Okay, it's designed all providers are global, and this is significant because keeping application state and logic inside of tree lead to poor separation concern. So yes, it's different. It's easy to get confused with too much providers. This is a very long article. I don't know, but I'm interested so far. Like if you don't want to read, if you want to read on your own, you can skip. So on the provider, we have one provider, then you may use this to access a repository logger or some other class that doesn't contain mutable state. That's where we use provider. So I was wrong. Provider can be, it's for data that is mutable. Not mutable means the data will not change. I just don't understand why you have to use provider to do this. You can just get this one. Contact with Riff, and you are watching this. And state provider is great for storing simple state object. For example, this in, and you build, and you can update the state inside a button callback with riff.read. So with watch, you watch this state for the counter state provider. And then you get the counter. This is the Flutter sample code. Get started with Flutter. Unpressed, when you on the button, you only read the value when you press a button. And .modifier.state. Okay. So the key point is not to memorize all the code stuff. I think the key point is to understand what problem they are solving, and why they are using this approach, which approach is best for us, and a comparison with different way management statement is also very useful to give us good understanding why we are doing this and what is a better way. So the best is you go through the code, I think, and then will be better to understand. I used this one before, the FutureProvider auto. There's a lot of API documentation on when to use what, and then you can watch this one, AsyncValue. This is good, very good syntax, because we have a FutureProvider where we defined in this value, in this level, like a global variable. Then in your UI, anywhere in the UI, you can get this. You see .when loading. So how do you know when is loading error or data? You get from here. We will need to see how they get the data on the details. Stream is very similar like the FutureProvider, ConsumerWidget. This is from the Flutter SDK. You always need to write this line of code, then it's easy to forget. Notifier provider, async notifier provider. Okay. The value of the provider inside the build method, we have always used the with.watch. listen to provider state. Okay, we just quickly go through to see what topic he covers. It's part of this module's reading. Additional feature, autoDispose modifier. I know this is for the autoDispose. If we use autoDispose, the provider will be disposed once all listeners are removed when the widgets are unmounted. Another use case for autoDispose when we are using FutureProvider as a wrapper for HTTP request. If we want to cancel this request, we can use onDispose function. So yeah, onDispose function, and you cancel the token. Catching the timeout. Family is another modifier. Again, he will explain more detail in the video, but it's still a good idea to read and understand ourselves before you watch the video. FutureProvider dot autoDispose. Oh, we already talked about that. Where's the family dispose? Family. Oh yeah, here. Additional argument of type int. You have a I'm not sure what this family is doing yet. Passing multiple parameters. In the case you may need to pass more than one value. When Riverpod does not support this, you can pass a hash code with freeze. Yeah, you read more later. So shared preference instant with a future-based API. Okay. Scoping provider. Oh, this one and then test. Okay. I want to learn more about test because in my company we are not doing much good testing. Okay, we need to save this one, and this one we don't have to. Okay, let's see what he's saying.
Welcome to this introduction to the Riverpod package. Is to manage. And if you really want, you can go quite far with the state management APIs that Flutter offers out of the box. And these include statefulWidget and setState, inheritedWidget, and useful classes such as changeNotifier and valueNotifier, along with reactive widgets such as valueListenableBuilder and animatedBuilder. And while I'm not going to discuss this in detail here, you should have at least a basic understanding of how they work. And if you want to explore this in more detail, I've included a good overview of all these APIs in this article, which includes many useful resources as well as some of the official videos from the Flutter team. And of course, there are also a ton of different packages that can help you with state management, including Provider, Flutterblock, RxStart, Gedit, MobX, as well as many others. And I can tell you with confidence that all these packages give you some very robust APIs for doing state management. However, as far as we are concerned, we are going with Riverpod, because Riverpod was created by the author of Provider to make some improvements that would be otherwise impossible. And since I've used Riverpod for over 1 year in all my apps, I can say with confidence that it is a very powerful solution for many different reasons, and we'll explore all these reasons in detail as we make progress. But before we move forward, I think it's useful to give you a conceptual understanding of what Riverpod really is. And the way I like to think of it is like this. At the core of Riverpod, we have a dependency injection system, which is something that we can use to declare all of the application's dependencies. And in our case, this will be the data sources that we connect to, as well as the repositories that give us the data that we need to show in our widgets. And as we will see, services and controllers are dependencies as well. And one very distinctive feature of Riverpod is that all dependencies can be declared inside global providers. That's right, all providers in Riverpod are declared as global variables. And what that means is that unlike with other packages, Riverpod providers live outside the widget tree. And this is something that you may find confusing at first, but trust me when I say that this was a very good design decision, because if providers live outside the widget tree, you can access them easily in multiple places without having to create complex widget trees, which was one of the big drawbacks of the provider package. And as we will see, we can still have providers that depend on other providers, and Riverpod gives us a nice and unified API for doing so. Alright, so what we said so far is that Riverpod can work as a dependency injection system that makes dependencies up. What we said so depend on other providers, and Riverpod gives us a nice and unified API for doing so.
I guess go back a little bit to
so
take
what
a
we said so
screenshot.
far is that Riverpod can work as a dependency injection system that makes dependencies available to our widgets by using some global providers. But beyond that, Riverpod is also a state management system that allows us to deal with various sources of data that can change over time. And in order to help us with all those different sources of data, we get specialized providers such as State Notifier Provider, StreamProvider, FutureProvider, along with some modifiers that we can use to tweak the way they work. And on top of that, providers can depend on other providers, tweak the way they work. And on top of that, providers can depend on other providers, and Riverpod is designed to do the right thing and rebuild providers as needed on our behalf. So we'll have plenty of time to explore.
So it's all the slide.
So we'll have plenty of time to explore Riverpod as a state management solution.
Every time you listen to the video slide.
In fact, I want to point out that the official homepage describes Riverpod as a reactive caching and data binding framework. So really, Riverpod goes beyond simple dependency injection and state management. And as we will see, we can use it to combine different types of providers in many interesting ways and configure it to do data caching and disposing things as needed. In fact, the master plan for Riverpod is quite ambitious and goes beyond what other state management packages do. And in the future, Riverpod will even be able to take care of data mutations for us by introducing some advanced features that will rely on static metaprogramming, which is a feature that is in the roadmap for the Dart language.
That's very interesting.
But as we wait for these advanced features to be implemented, we can already make the most of what Riverpod offers today. And as we will see, there is already a lot of good stuff to keep us busy. And the main takeaway of this lesson is that just like widgets are the primary building blocks for building apps with Flutter, providers are the primary building blocks for managing state in Riverpod. And in fact, the main purpose of a provider is to encapsulate state and to make it possible for widgets to listen to that state and rebuild themselves when it changes. And if we explore the official documentation, we can learn that there are various providers that were created to deal with different use cases. And as we make progress, we'll focus primarily on these four since they are the most useful ones. So let's continue on the next lesson where we'll install Riverpod and start using it.
Okay, he's just talking about all these stuff. There isn't much new. Now we are getting to the code, I think.
In this lesson, we're going to install the Riverpod package and set things up so that we can use it in our app. And if we go on the official page for Riverpod, we can find that there are 3 different packages called Flutter Riverpod, Hooks Riverpod, and Riverpod. So which one should we use? Well, as we can see, Riverpod is a pure Dart package that does not depend on Flutter itself. And this could be useful if you wanted to write server-side Dart code or perhaps a command line tool built in Dart. But as far as we are concerned, we are building a Flutter app, so we have to choose either Flutter Riverpod or Hooks Riverpod. And the difference between these two is that Flutter Riverpod is the main package that is used in most projects, and instead Hooks Riverpod is a separate package that gives us a way to use both Flutter Hooks and Riverpod together. And when it comes to managing the widget lifecycle methods, Flutter hooks are a great solution to reduce boilerplate code, and they can replace stateful widgets altogether. However, we are not going to focus on Flutter hooks at this stage, because for now it's much more important that we learn how to use Riverpod as a state management solution. And this means that the package that we want to install right now is Flutter Riverpod. And as I record this video, Riverpod 2.3.6 is the latest version available, and this is what we will be using. And by the way, one thing that I should mention is that alongside the Riverpod 2.0 release, a new Riverpod generator package was also introduced. And the purpose of this package is to make it easier to create various kinds of providers with a new modern syntax that build on top of the existing APIs by using code generation. But just to be clear, most of this course will focus on the main Riverpod package so that we can really understand how to use it on its own. And I will cover the new Riverpod generator package as a separate section at the end of the course and share some new articles and resources that you can use to learn how to use it. Okay, so let's get back to VS Code.
Okay, so yeah, we are not doing the Riverpod, we are using the Riverpod Flutter. I'm just curious. Flutter. Oh yeah, Flutter Riverpod. Restorable. Wow. Who made all these? Okay, let's stay with this one. So it's 2.5. So when his recording is 2.2. So I believe there isn't big changes. What is this? Niftify. Does this have anything to do with the widget? I mean the package? No. Okay. Let's go to the code, and I guess you just Command Shift P. Oh, see. Command Shift P. Dart add dependency. Then you type Flutter Riverpod. That's it.
And at this stage, we need to grab the updated starter project for this section. So please go ahead and open the terminal, and then from here you can run git reset -- hard head.
This is important, but I think it's not necessary for me because he basically say he remove all the changes you had before and check out into the section 4 starter. I did already. Because we don't have much changes from last time, we can just continue.
To discard any working changes, and then you can get the new starter project by running git checkout section 04-starters, like this. And now that we have done this, we can head over to the pub/spec.yaml file. And as we said, we're going to use Riverpod version 2.3.6. So let's copy this version from here, and then we can go back here and paste it. And just to be clear, one thing that we have said is that we want to use the Flutter_Riverpod package. And I recommend that you use exactly this version to make sure that your code is in line with the course project.
So he get Flutter Riverpod 2.3.6. I don't know what he's mentioned about copying the Riverpod. It should be Flutter Riverpod.
And now that we have done this, we can save and get delayed.
So in the video, it's different version. Let's stay with the latest, and we can change along the way. He probably already updated his code base into the latest anyway. But the video recording is about 1 or 2 years ago.
Packages. And now we can start using Riverpod. And the first thing that we need to do every time we add the Riverpod to a new project is to go to the main.dart file. And then what we want to do is to focus on this line, which is used to run the app by passing the root widget. And what we want to do is to wrap this widget with a provider scope, which is a widget that we need to import from Flutter Riverpod, like this. And then we can save our.
Go to main.dart. In my app, wrap with a widget. Provider scope. Like this. The const. Yeah, you need to change. And we can read what's this. It's a widget that stores the state of provider. All Flutter applications using Riverpod must contain a provider scope at the root of the widget tree. This is done by follows. It's optionally possible to specify overrides to change the behavior of some provider. For example, override the behavior repository provider to provide a fake implementation for test purpose. So your repository provider is the real data, and you say, okay, no, in this test we are using the fake repository data. Similarly, it's possible to insert other provider scope anywhere inside the widget tree to override the behavior of a provider for only a part of the application. What's this talking about? For example, StreamProvider. Material app. So let's go up. Home. We have two provider scope. Another overrides the theme provider for list routes. Interesting. Okay. Keep going.
And run our app on any of the available devices. And just to be clear, it is absolutely critical that we add a provider scope at the very root of the widget tree, because this is a widget that maintains the state of all the providers that we will create inside our app. Okay, so at this stage, you should have the app running over here, and we can continue on the next lesson.
Continue. Slow. Almost an hour already.
In this lesson, we're going to learn how to use Riverpod as a dependency injection system and start getting familiar with the Riverpod APIs. And if you remember, the last thing that we did in the previous section was to create this fake products repository class as a singleton that we were then accessing in all these different widgets. And what we said back then is that using the singleton pattern like this is not a good idea. And the reason it is not a good idea is that using singletons in our widgets makes them hard to test. And we'll discuss testing much more in depth in one of the upcoming sections. But for now, all I want to say is that if we have a widget that depends on a repository, such as this one, then it's not possible to replace this repository with a different one that we use.
Right, he pointing on the product grid. In the product grid here. So this is the same everywhere where this is how we get the product. And when we have real data, and if you write code like this to get the data, it's hard to test. That's what he means, and I agree.
Test purposes. And that's because when we use singletons like this, what we are doing is hard coding dependencies inside our code. So let's see how we can address this by using Riverpod as a dependency injection system. So what we are going to do next is to declare a provider that will give us access to the fake products repository. And then inside our widget, we will find a way to use that provider and get the repository. So let me show you how this all works in practice. And the first step is to open the fake products repository. And what we want to do is to declare a provider. And if you haven't done this already, I highly recommend that you install the Flutter Riverpod Snippets extension by Robert 𝒂𝒂𝒂𝒂𝒂𝒂, as we will use it extensively.
I think I have. He mentioned to download this one.
Going forward. Okay, so let's get back to our fake products repository, and then we can scroll over here to the bottom, and then we can start typing provider, and then we can select the first option that appears on this list. And as you can see, this generates some boilerplate code for us, and what we had to do is to give a name to this provider, such as products repository provider, and we must also give it a type, which in this case is fake products repository. And we need to remember to import Flutter Riverpod. And
so final product repository, you just give a name, provider, and the naming is hard. Provider. Then you have the ref. Yeah. Luckily, let's see. What do we want?
see, this provider takes one argument, which is an anonymous function that gives us a ref object. And I'll explain what this ref object is very soon. But for now, we don't need it. And all we had to do is to return an instance of our fake product repository. And right now, the only way we can do this is by calling .instance, like this, because we have declared this as a singleton. And as we will see in the coming lessons, we will always use this provider to retrieve this repository. So strictly speaking, we no longer need this to be a singleton. But for now, let's stay on track and leave it like this, and we'll remove this singleton declaration later on. And by the way, this syntax that we have just used is something that we will use over and over. And when creating providers with Riverpod, there are three things to keep in mind. The first one is that providers are declared as global variables, like we have done here. And this means that anywhere in our project, we can access this provider as long as we import the file where it is declared. The second one is that providers always need a type annotation, and this tells us exactly what type of object they return. And the third one is that providers have a body, which is a function argument that we can use to return an instance of the type that we have specified. And in this case, we are just returning this object as a single line. But as we will see, this function can be quite complex, and we'll be able to use this ref object to access other providers as dependencies. And just for reference, this syntax is quite different to what you may be used to if you use the provider package, where all providers are widgets themselves that are inserted directly in the widget tree. But as it turns out, declaring providers as global variables is a much better design decision, and we'll see the advantages of this going forward. However, it does mean that we need to choose where in our code we should declare these providers. And while there isn't any recommended guidance on this, what I found works well in practice is to declare providers in the same file where we declare their type, like we have done over here. And just to be crystal clear, Here we are declaring a provider of type fake products repository, but in fact we can create providers of any kind of type in Dart, including primitive types such as string or integers, booleans, and so on. And for now, this is all we need to know. So let's remove these two providers and we can continue on the next lesson where we will see how to use this provider.
So my next lesson will be, it's not synced on my Mac, so it will be number 5. Part 2 or part 1, number 5. It's a long lesson. Let's take a short break, okay? I'll come back soon. Okay, it's almost 12 p.m. here in Canada. I'm going to take a short lunch break, but as you can see on my screen, there is quite a few very good Flutter video than worth watching. So be free to skip the lesson, watch on your own, or you can watch on my channel as well. So I will just skip, so you don't need to see me eating. Let me see.
If you use the Flutter Lens package, which as of its 2.0 release added the use build context synchronously rule, you may be seeing some new red squigglies in your Dart code. But what does this mean, use build context synchronously? If you include this rule to your linting setup, either by adding a dependency to your Flutter Lens 2.0 or by specifying it yourself, your editor will start complaining about situations like this. Flutter knows that build contexts are
Okay, this is good. I got this error before. I never understand.
Unreliable after an asynchronous gap, and it wants you to know that too. The first follow-up question in better understanding this is, what are you talking about? Remember that the build context passed to a widget is that widget's corresponding element in the element tree. Also remember that, while lots of our application code is asynchronous, Flutter's build process is 100% synchronous. There are no awaits, no futures anywhere in the assembly of your widget tree. And finally, recall the unique relationship between elements and their widgets. As Flutter developers, we mostly write widgets, so it's easy to think that they are the primary object in the relationship. But widgets are ephemeral, living as briefly as 1/120th of a second if your app is animating something across a high refresh rate screen. We see here that widgets come and go, but where possible, Flutter keeps elements around. This is a huge driver of Flutter's incredible performance, despite how wasteful it can seem to throw all these widgets away after only using them for a few milliseconds. Now, I said Flutter keeps elements around where possible, and this distinction is a part of why asynchronous use of build context can be so unpredictable. There are many different scenarios that can make Flutter decide that some of your elements need to be refreshed, from scrolling to navigation events to dragging and dropping, but it's not worth trying to memorize them all. For our purposes today, let's just use the following rule of thumb. The more dramatically your widget tree changes from one frame to the next, the more likely Flutter is to need to update portions of your element tree. And for every new frame, it's always possible that a given widget's element has been removed from the tree. Unpredictable events from your user can force Flutter to reassemble the element tree at any moment. So the only safe way to build your widget is to avoid asynchronous usage of a build context. But this is just a new lint, so if your code is anything like mine, when this lint arrived, you would have found some places where you were breaking the rule, and probably your app wasn't catching on fire. So what's the deal here? Part of the issue is that after an asynchronous gap, your widget's build context could be a ticking time bomb waiting to explode the second you touch it, or it could be totally fine. Let's look at some code. Consider this situation where a button's callback submits a form and then pops the current page. The new lint rule will tell you that this line is risky, but why? If you look up the lint online, you'll see a suggestion to return early if your widget is no longer mounted. And this gets to the crux of the issue, because certain events, like use, gets to the crux of the issue, your widget is no longer mounted.
This is, oh, sorry. I'm just wanting to, sometimes I make notes so I know where to avoid this. I like how
Your widget
accent.
is no longer mounted. And this gets to the crux of the issue, because certain events, like user scrolling, navigation, and several others, may have already removed your widget's element from the tree. It's unsafe to call the famous .of methods, as passing stale build context to those methods can crash your app. Back to that lint. The recommended fix is to do this. The reliable way to confirm your build context is still valid is to check the mounted property on a state class. And the fix works for this scenario too. Because if this widget is no longer mounted, something else may have already removed this page. But does this always work? Imagine this scenario where instead of removing the page, you want to show a snack bar that informs the user of an action's outcome. Does the if not mounted return check still serve our purposes? Probably not, because even if the element has been disposed, we still want the user to see confirmation of their action. In that case, don't conditionally return early if the widget is unmounted, but instead hold on to the resources you need ahead of time and then use them after the asynchronous gap. Here's a tricky one. What about this code, which crosses an asynchronous gap, then uses an at-risk build context to read the media query, update some layout calculations, and call setState? First and foremost, we know that if somehow the user has navigated away from this screen or scrolled past this widget in a list view that uses the builder constructor, then our media query.of call is doomed. Also, if this widget is no longer mounted, then we definitely don't care about updating any measurements for its children. So it's safe to use the mounted check. But what if it is still mounted? Can an aged build context safely read the media query and give us up-to-date values? What if the user resized the window during the await? Good news. In this case, Flutter will do the correct thing, and you don't need to worry. Now, it is worth noting that this code is a pinch contrived. Normally, code like this lives in the main area of your build method. But if you watch the previous Decoding Flutter episode about change dependencies, you may be spotting an opportunity to improve this widget's performance. Just like we talked about in that episode, because this code will only produce new values when the media query changes, and the media query changing will always activate your widget's change dependencies method, you can certainly move this code into that method and ensure it's only ever run when it can possibly produce new values. And this pattern is great because it allows us to only perform calculations and cache values once, precisely when our old values grow stale. And our build context is always synchronous and fresh. Asynchronous use of build context is one of those things that's fine until it isn't, which is the reasoning behind the new lint. For more info on Flutter, head to flutter.dev.
That's a very good one. This is older, but we can listen again.
One of Flutter's most efficient tricks is ability to use a build context to look at widget tree for something of interest. The most common of these are median query of context and same of context. But popular state management solutions like Flutterblock and the provider is the same mechanism. And the pattern really is a godsend too, because without it, every leaf widget that cares about the median query would have to accept it as a parameter from their parent, meaning every one of their ancestors would have to accept it as a parameter too. This would couple every widget in your app to their position in the widget tree. Imagine the refactoring pain. But the pattern is even more useful than merely preventing a thick jungle of parameters. Simply having a widget run the line of code, median query of context ties the widget to the median query, meaning it will get rebuilt whenever the median query changes. And this is important because if you are laying out a widget based on the screen size, that layout is unlikely to remain valued if the user rotates their phone or expands their desktop window. But how does this work? Just writing median query of context registers the widget as a listener to the median query? Really? Yes. Let's pull back the curtain. First, it's helpful to remember what the ubiquitous context variable actually is. You may recall that Flutter has 3 primary trees: the widget tree, element tree, and render object tree. Into each widget's build method is passed its corresponding element, which is actually a subclass of build context. So when your widget assemble themselves with the use of a build context, it's like they're talking to a more knowledgeable version of themselves from another dimension.
Cool.
Next is that of method on the median query class that we call all the time. It's a static method that returns a median query data instance, and internally it calls context.depend on inherited widget of exact type, which can find any inherited widget in constant time. The last line not only returns the median query data instance we care about, but also registers the widget that called it as a dependency of the median query. Our widget element is added to a special list that the median query will mark for rebuilding whenever it changes. And if you are wondering how other packages like Provider work, it's by doing exactly the same thing. Remember Provider's listen parameter? If you set listen to true, Provider calls context.depend on inherited widget of exact type. That's how the Provider package is able to watch a provider and automatically rebuild. As a side note, if you set listen to false, Provider calls a similar method, get element for inherited widget of exact type. It's similar, but doesn't create a dependency. Technically, you can call these methods yourself, but the suggested pattern here is to use the static of methods we all know so well. Now, there is a few gotchas here. The documentation warns against calling off-context methods during widget constructors or init state, saying those methods won't get rerun if you do. In fact, the framework will throw an exception if you try to depend on an inherited widget from within the run method. The only safe place to call this method is in state.didChangeDependencies or build methods. Now, how does this work if you call this method from init state? Somehow, the framework knows you cheated and won't schedule that widget's init state to be rerun? The answer is that Flutter always knows what phase of the widget lifecycle it currently is. So the static of methods first check to make sure you are in the active phase, which contains did change dependencies and build. And if so, the inherited widgets element registers your widgets element as a dependent. Init state lives in a different phase, which is incompatible with this system, because initialization only happens once. So it wouldn't make sense to schedule init state to be executed again in the future. Initialization that happens repeatedly would just be Groundhog Day. Initialization that happens repeatedly, so you can call the static of context methods during did change dependencies or during a build method. But what's the difference? You might already be familiar with the build method, but few Flutter developers have spent as much time thinking about did change dependencies. First of all, what even are those dependencies its name references? Many developers intuitively assume they are the widget's ancestors or something, but no. It's the dependencies created by the depend on inherited widget of exact type. For example, if you register your widget with the thing Then, when the theme changes, your widget's _change_dependencies method will be called first. Then afterwards, its build method will be called. Deciding where to put your off-context method calls involves understanding a few trade-offs. Actually, finding the essential widget is cheap, but where you call it only matters if you are doing something expensive with the result. If you only need to run your fancy logic when the theme or the median query or whatever changes, you can consider caching a computed value in the _change dependencies and then referencing it in your build method. And it's worth holding here to truly understand why this works. If you are loading new assets or performing expensive calculations that depend on the inherited widget, then it stands to reason you wouldn't need to reperform the operation until the inherited widget changes, which is exactly when _change dependencies is called. Of course, if you're not doing anything expensive, you can always just put that code right in your build method. This is a standard pattern we all tend to use 99% of the time. To be clear, the performance difference here is very small, but Flutter apps have a lot of widgets, and especially during animations, when dropped frames are acutely painful. This small difference would add up across your app. If needed, you can also implement your own inherited widgets too, but that's rarely necessary. For more things, just use Provider. Hopefully, this helps demystify the magic line of code we've all written 1,000 times. For more information on Flutter, head to flutter.dev.
Have you ever wondered what happens in those milliseconds between frames? Those pixels don't just magically appear on screen. So what does happen? This is the job of Flutter's multi-phase rendering pipeline. It's Flutter's job to handle input, run animations, build the widget tree, lay out the render objects, paint the render objects, and composite everything into a single image. Whenever part of the widget tree receives user input, animation, or changes in some way, Flutter enters the build phase. In this phase, the framework reconstructs the widget tree by calling only the necessary build methods. The build phase updates the element tree, which updates the render object tree. Render objects are responsible for layout and painting. During the layout phase, Flutter walks the tree of render objects, passing down constraints. Most widgets use box constraints, which are two-dimensional constraints for a specific type of render object called a render box. Child render objects pass up a size to the parent object. The size of the render box has to be within the constraints that were passed down. So when you're debugging layout issues, you can take a look at the incoming box constraints passed to the render object in question and see what size was calculated. Once the layout phase is complete, Flutter enters the paint phase. This is where Flutter calls the paint method on all the render objects. Render objects paint onto a canvas using methods like drawRect and drawLine. If a render object has children, it should paint those in its paint method too. Calling paintChild seems like something the framework should do, but actually it allows the render object a lot of flexibility. For example, a render object can draw more on top of its children. After the painting is done, it's time for the compositing phase. Compositing means combining images into a single picture. But what do we need to combine? Well, painting doesn't happen on a single canvas. To see why, think about scrolling a block of text. When the user scrolls down, we shouldn't need to update the text again, only the scroll bar. We just need to reposition the text. To solve this, Flutter uses another tree, the layer tree. This tree contains all the paint operations for each layer. Lower layers are painted last, and everything is sent to the Flutter engine to be rasterized. By the way, each layer is painted separately, so Flutter tries to group multiple render objects into the same layer. But if you wrap a widget in a repaint boundary, Flutter will give its render object its own layer, and this can be a way to avoid extra painting. Finally, the engine receives the updated layer tree containing the drawing instructions and converts them into pixels. This is a process called rasterization. If parts of the layer tree remain unchanged, the engine can reuse those pixels. So don't forget to try a repaint boundary if you're seeing a lot of unnecessary painting. Creating a separate layer can be a useful tactic for performance. For more on Flutter's render pipeline, check out the links below and head on over to flutter.dev. Have you ever wanted to use non-Cartesian coordinates? Or maybe you're looking to build a widget that you just can't build using the available widgets. If you've used Flutter, you've probably built a widget tree before. You might also know that Flutter creates an element tree alongside it. But what do these elements do? They create another tree of render objects called the render tree. You're probably most familiar with the widgets layer, but what about the layer below? This is the rendering layer, which deals with render objects and their related classes. The widgets layer uses the rendering layer, so you don't typically see render objects in your code, but they're there. But what do render objects do? Well, quite a bit actually. They deal with layout, painting, hit testing, and accessibility. You probably already know that everything is a widget in Flutter. But it's also true that everything you see on screen is a render object. To see for yourself, open up the Flutter inspector and select the Render Tree tab. Most Flutter widgets use a specific type of render object called renderbox, which uses 2D coordinates. The element tree keeps the render object tree in sync with the widget tree and continues to exist from frame to frame. Most of the time, the render objects can be reused, which helps improve performance. For example, if the color of a widget changes, the same render object can be reused and repainted. If a widget is removed from the tree, the corresponding element is detached, and so is the corresponding render object. This detaching happens because the render object might actually be moving to a new location in the widget tree, or swapped with a sibling. This is why it's important to use keys. Flutter uses keys to figure out when a widget has moved to a new location and might be able to reuse the element and render object. For example, when two stateful widgets with unique keys are swapped during the build phase, the elements need to be swapped too. The parent element will reuse the child elements if there's a widget with a matching key. In effect, swapping the elements and the associated state objects. If you want to move a widget to a completely different part of the tree, you need a global key. For more on keys, see our When to Use Keys video. To customize the layout and painting of a widget, extend renderbox or render object and override their methods. Then extend the render object element and render object widget classes if you're using the widgets layer. But this is a lot of code, so before you get started, you should make sure that there's not a way to use widgets instead. If all you're trying to do is paint onto a canvas, try the custom paint widget. For more on Flutter's render pipeline, check out the links below and head on over to
Hey, I'm Emily from the Flutter team. In this video, we're going to talk about using the key parameter on widgets. If you're wondering what the heck a widget is, I recommend going back to the first video in the series where we introduced the building blocks of Flutter. Keys preserve state when widgets move around in your widget tree. They can be used to preserve the user's scroll location or keeping state when modifying a collection. In this video, we'll cover 3 things: when you need keys, where to put them in your widget tree, and which key is right for you. So, when do you need to use keys? Most of the time you don't. But if you find yourself adding, removing, or reordering a collection of widgets of the same type that holds some state, it's key time. No, key time. An example of this is a to-do list app. When using the app, you want to reorder the items based on your to-do list based on priority, and then remove them when you're done. Another example is the Hacker News app in the Flutter Boring Show. Adding keys prevented the story widgets from incorrectly picking up old state when the list view was rebuilt. To illustrate why you need keys in this situation, I wrote an extremely simple app with 2 randomly colored widgets that swap places when you tap a button. Here's the code for the app. It consists of a stateful widget called position tiles that constructs 2 stateless tiles and places them in a row. When I tap the floating action button down at the bottom, it swaps their position in the list as expected. But what happens if we make those colorful tiles stateful instead of stateless and store the color in the state? Now when I hit the button, it looks like nothing is changing. But if I add a key to each tile widget, the widgets swap places like you expect. Remember though, if the entire widget subtree in your collection is stateless, keys aren't needed. Technically, this is all you need to know to use keys in your apps for most simple situations. Now that everyone's left, we can go into how keys work under the covers when Flutter renders these widgets. In the stateless widget version, the row widget has a set of ordered slots for its children. As you've seen in the earlier episodes of this series, for every widget, Flutter builds a corresponding element. The element tree is extremely simple, only holding information about the type of each widget and a reference to children elements. You can think of the element tree like a skeleton of your Flutter app. It shows the structure of your app, but all the additional information can be looked up via reference to the original widget. When we swap the order of the tile widgets in the row, Flutter walks the element tree to see if the skeletal structure is the same. It starts with the row element and then moves to its children. The element tree checks that the new widget is the same type and key as the old one, and if so, it updates its reference to the new widget. In this case, the widgets don't have keys, so Flutter just checks the type. It does the same for the second child. Now let's run through the same scenario again, only this time with stateful tile widgets. You can see I've got the same widgets and elements as before, but now there are a pair of state objects with them, and the color information is being stored there, not in the widgets themselves. So this time, when I swap the order of the 2 widgets, Flutter walks the element tree, checks the type of the row widget, and updates the reference. Then, tile element checks that the corresponding widget is the same type, a tile widget, and it is. And it does the same for the second child. Flutter uses the element tree and its corresponding state to determine what to actually display on your device. So from our perspective, it looks like your widgets didn't properly swap. In the second version with the stateful tiles, I added key properties to the widgets. Now if we swap the widgets, the row widgets match like before, but the key of the tile element doesn't match the key of the corresponding tile widget. So Flutter deactivates those elements, removing the references to the tile elements in the element tree, starting with the first one that doesn't match. Then Flutter looks through the non-matched children for an element with the corresponding key. It finds a match and updates its reference to the corresponding widget. Flutter then does the same thing for the second child. Now Flutter will display what we expect, with the widgets swapping places and updating their color. So in summary, keys are useful if you're modifying the order or number of stateful widgets in a collection. For the sake of illustration, I stored the color as state in this example, often though state is much more subtle. Playing animations, displaying data that the user has entered, and scroll location all involve state. So, you have a scenario where you need a key for your app. where do you put it? The answer is to specify a key at the top of the widget subtree that you need to preserve. Since we've been talking about state so much, you might think that it's the first stateful widget, but you'd be wrong. To show you why, I wrapped my colorful tile widgets with padding widgets, but I left the keys on the tiles. Now, when I click the button, the tiles change to completely different random colors. What's going on? Here's what the widget tree and the element tree look like with the padding widgets added. When we swap the positions of the children, Flutter's element to widget matching algorithm looks at one level of the tree at a time. I grayed out the children's children in the diagram so we can focus on one level at a time. At that first level of children, everything matches up correctly. At the second level, Flutter notices that the key of the tile element doesn't match the key of the widget, so it deactivates that tile element, dropping those connections. The keys we're using in this example are local keys. That means that when matching up widgets to elements, Flutter only looks for a key that matches within a particular level in the tree. Since it can't find a tile element at that level with that key value, it creates a new one and initializes a new state, in this case, making the widget orange. The same problem happens for the other tile. If we add keys at the level of the padding widgets, Flutter notices the problem and updates the connections correctly, just like it did in our previous example. Order is restored in the universe. So, now you know when to use keys and where to put them. But if you looked at the Flutter documentation, you'll see there are several different kinds of keys, so which one should you use? In the scenario where you're modifying a collection of widgets, like the swapping colored tiles example, you only need to distinguish between the keys of other children. Take a look at the information you're storing in those child widgets to help understand what widget to use. In a to-do list app, we might expect the text of a to-do item to be constant and unique. If that's the case, it's probably a good candidate for a value key, where the text is the value. Now suppose that instead, each child widget stores a more complex combination of data. Perhaps you had an address book app that listed information about each user. Any of the individual fields, like a first name or a birthday, might be the same as another entry, but the combination is unique. In this scenario, an object key is probably most appropriate. If you have multiple widgets in your collection with the same value, or if you want to really ensure that each widget is distinct from all others, you can use the unique key. I used a unique key in the example app because we didn't have any other constant data that we're storing on our tiles, and we don't know what the color will be until we construct the widget. But one thing you don't want to use is a random number in your key. Every time a widget gets built, a new random number will be generated and you'll lose the consistency between frames. Then you might not as well have used keys in the first place. Page storage keys are specialized keys that store a user's scroll location so the app can preserve it for later. Global keys have two uses. They allow widgets to change parents anywhere in your app without losing state, or they can be used to access information about another widget in a completely different part of the widget tree. An example of the first scenario might be if you wanted to show the same widget on two different screens, but holding all the same state. You want to use a global key. In the second scenario, maybe you want to validate a password, but you don't want to share that state information with other widgets in the tree. Often though, global keys are a little like global variables. There's usually a better way to look up that state using inherited widgets or something like Redux or the block pattern. So in summary, use keys when you want to preserve state across widget trees. This most commonly occurs when you're modifying a collection of widgets of the same type, like in a list. Put the key at the top of the widget tree you want preserved, and choose the key type that you're using based on the type of data you're storing in that widget. For more documentation, check out flutter.io. Happy creating.
Thanks. Very good.
Sometimes there's confusion between the ideas of async and isolates, concurrency and parallelism. Let's clear that up. A code like this is asynchronous. It runs normally and then it waits while a file is being downloaded. While it waits, other parts of our program can run. Notice how there's always only one part of the app running at any given time. After all, we're running on only one thread, one processor. Async doesn't automatically make your app multi-threaded. After the file is downloaded, the method will continue. That's async. The processor doesn't need to stop and do nothing until the download is finished. It makes a mental note to get back to that particular method, basically a callback, and when that feature completes, it goes back there. Most of the time, async is all you need. But what would happen if the method does some heavy computation? Let's say the file is huge and parsing it requires a lot of processor power. Will this make our app stutter? You might think, no, it won't. The computation happens in an async method, right? But unfortunately, you're wrong. The app will stutter because even though the method is asynchronous, a large chunk of synchronous work is happening inside it. That parsing is synchronous. It's happening on your thread. That will keep the processor busy, and so no other part of your app will be running. The UI won't refresh until the heavy work is finished, and the user will see stutter. So busy, and so that will keep the processor busy, and so no other part of your app will be thread.
So even though we are waiting for a network, but after that we have a synchronous heavy computation, that will cause an issue.
That will keep the processor busy, and so no other part of your app will be running. The UI won't refresh until the heavy work is finished, and the user will see stutter. What you want in this case is parallelism. Dart allows you to run code in parallel via isolates. With an isolate, you start another Dart program, basically, on a different thread, on a different processor. The two separate isolates are isolated. One will not block the other. This way, your app can do heavy processing while also running smoothly for the user. I won't get into how to implement isolates here. It's a bit more involved. And this video is only meant to distinguish between the two concepts of async versus isolates. Speaking of which, let's summarize. Async is the ability to wait for other things without blocking. Async will not create a separate thread for you. Dart will just jump between the different parts of your program as needed. In most cases, that's fine. It's like if I talk to you and also sometimes check my phone. When I'm checking my phone quickly, it's fine. Kind of annoying, but fine, right? Our conversation still flows. But if I suddenly start staring at the screen and ignoring you, then that's not great. That's async. Isolates give you the ability to run things in parallel. One isolate doesn't care what the other one is doing at any given time. They can both run at full speed. Isolates are harder to set up, but it's also the only way to deal with some situations, like the parsing example I mentioned. Isolates are like when I talk to you and also play around with Dash here. I can do those things in parallel. All right, I hope that was helpful.
That is indeed very helpful, and I will attach all the videos that included in this session.
So you've learned what a widget is, and even started writing some of your own.
They are all very cool.
Every single one of these widgets build methods takes in this build context thing. You know you need it, and things like Navigator, Media Query, and various builders need it. But what is it? Remember back to what a widget is. It's a blueprint or a recipe for what that part of the UI should be. But like words in a book, they don't appear in isolation. Rather, they appear alongside other widgets. But how does a widget know where it is in relation to those other widgets? Well, it doesn't. Since the blueprint can be reused just about anywhere, the widget itself doesn't keep any information about where in the tree a specific instance is. The secret here is that there's more than just a widget tree. Let's suppose you've created a new widget, either extending from stateless or stateful. If you poke into the implementations of these, you'll see that both are themselves implementations of the class widget. Looking at the list of methods in a widget, there's not much more here than what's in most Flutter and Dart classes, but one in particular stands out to me. This create element thing that says something about a concrete instance. These elements are the objects that actually keep track of where a specific widget is, and therefore what its parent and children are. So when you build a new widget, the Flutter framework calls that widget's create element method. The element it returns maintains the information needed at runtime for this widget in this part of the app. At that point, the element is effectively a node in a tree of other elements of the app.
What?
At that point, the element is effectively a node in a tree of other elements, each with a reference to the widget they represent.
Very good.
And what is an element? It's just a type of build context. So the next time you see a media query.of context, replace context in your head with thing that allows my widget to figure out where my widget is. In other words, it gives your widget's build method the context it needs. For more on elements, build contexts, and all things Flutter, head on over to flutter.dev.
Did you understand? I'm always half understanding, but I'm really curious.
Coming to Flutter from another system like Android or iOS, it's tempting to map what you already know about activities or view controllers onto widgets. Those things have life cycles, and widgets are the closest analog in Flutter, so they have life cycles too, right? Well, not really. To understand more, ask yourself, what is a widget exactly? And to understand how widgets are different, let's take a step back and consider what widgets actually are and how they fit into the Flutter framework. Consider an analogy. Let's say you want to bake a fancy multi-layer cake with different flavors throughout and a unique homemade frosting on top. You probably don't just bake this cake. Instead, you follow a set of instructions specific to each and every component. These recipes, even if you wrote them yourself, don't change while you're in the middle of making the cake. After it's done, and after you've sampled a piece, you might decide that the frosting isn't quite right. And so you go and tweak the recipe for it, adding more sugar. And there's nothing you can do about the current frosting, but the next time you bake the cake, the frosting will be a bit sweeter. Your Flutter app is kind of like the cake, and the widgets are kind of like the recipes for the frosting, the batter, or the decorations. Just as you would use the recipe to create a cake, Flutter will use the widgets to determine what to draw on the screen. You can't change an existing cake into a different one by modifying the recipe after baking it without some timey-wimey wobbly stuff. But in the same way, Flutter widgets are immutable. Once they're created, they can't be changed. But an app has to respond to events, like user input or animations, and so there must be some way of changing the widgets, right? Flutter handles this by rebaking whole parts of the cake. When your app needs to change, it gives Flutter a new set of widgets. This might sound like a lot of work, but Flutter is designed to handle updates to the widget tree very efficiently. Behind the scenes, elements and render objects keep track of where the widget is in relation to other widgets, whether things need to be rebuilt based on state, and updating the screen as needed. So, does your widget have a lifecycle? Not really. Your app either needs that recipe or not, and so the widget is either built, rebuilt, or not used at all. For more on widgets and the rest of Flutter's internal architecture, head on over to flutter.dev.
Let me see. Okay, let's continue after a long lunch break. During the lunch break, we watched a few videos. I will add the link into this video, and those YouTube Flutter video are very, very good to help us understanding how the internal works. So you don't have to watch with me. You can skip. And in last session, just to recap, we are in module 4, and you should check out the GitHub branch on section 4. And we are going to go through the number 5, reading provider, and we didn't do much code yet. We just add the package, add one provider, and reading. Let's see this one.
In this lesson, we are going to learn how to use this provider in our widgets. And as part of this, we will learn about two important Riverpod widgets known as ConsumerWidget and Consumer. And as we know, there are currently 4 places in our project where we access our fake products repository instance. For example, we can open the products grid widget, and as we can see, in the build method, we access the list of products.
So he search the file by .instant, where we created a instant. Yes. We created this shouldn't be this one. The product. Yeah, the product instance. So we did this in module 3, and it's a temporary solution. And we discussed in earlier video, in the same video, why this is not a good way to get the even though it's a real data. And using provider will give us an alternative way to, it's called in Dependency Injection, right? And in this way, we can get data from the provider. So if we want to do the test, we just mock fake data, but in the provider, we will use the real data. This is just temporary because we are not connecting with the backend yet. So I guess we will need to change the code with the provider to consume the data.
This syntax. So let's see how we can change this to use the provider that we have declared. And a very important thing to understand is that when we use Riverpod, we should always access our providers by using a so-called ref object. And the easiest way to get a ref object is to convert our widget parent class to ConsumerWidget. And in order for this to work, we need to import Flutter Riverpod. And when we do this, we get an error on the build method because
we have some notes. Okay, no, if you have a stateful widget, you should replace with stateful consumer widget instead. Okay, yeah.
Riverpod. And when we do this,
how did he do
Riverpod. And when we do this, we get ConsumerWidget.
Wait.
By using a
we can only access provider with the
ref object. And the easiest way to get a ref object is to convert our widget parent class to ConsumerWidget. And in order for this to work, we need to
Okay, so ConsumerWidget and import.
Flutter Riverpod. And when we do this, we get an error on the bit method because the bit method of ConsumerWidget gives us two arguments. The first one is a bit context, and the second one is a widget ref argument called ref. And just like the bit context allows us to access other widgets up in the widget tree, the widget ref object allows us to access all the providers that we have declared. In fact, now that we have this, we can remove this to do, and then we can type final products repository equal to ref dot. And as we can see, here we get a list of methods, and I'll explain what these methods do later on. But for now, the one that we want is called watch. And this takes an argument, which is the name of the provider that we have declared in this file. So we can copy the name of this provider, and then we can paste it in here.
Why you call it products repository? Interesting. We are using watch the product, and this is from here. Great. I guess the next step is we will change all of these.
Yes. And now that we have this, we no longer need to use this singleton, and instead we can just type products repository.getProductsList. And just to be clear, if we hover over this provider variable, we discover that its type is provider of fake products repository, as expected. And if we hover over this variable, we find that the type is fake products repository, because this is what the provider returns. And now that we know this, we can update all the files where we were using a singleton to use this new syntax. So let's copy this line from here, and then we can open the shopping cart item widget.
So the ref.watch will only return, this repository. That's why we named the repository. But we still need the products, which we will use from here. But we say repository. What happened? Okay, repository dot get products, and then we still get product. And should we use watch or read? And watch, and then we will need to change everywhere where we used, for example, in here, which is order item list tail. This is to get products. See, we start typing, and before we watch a video, which is good. So here you see we get this. We need to get the product, and we will say, hey, get product, not list. The product ID. Like this, but this one, God, do we have to add? Yeah, we need a better way of dealing with this. This is not safe to, but the same. Shall we just copy product screen? Just copy this. Go to the These are all together product ID, right? Oh, we need to change this again. Consumer. I wish there's a quicker way on doing so. Widget with we already have product ID. This is better. Now we go to that's good. Shopping cart. And again, we need to change this to consumer. Is there a shortcut? I'm just curious. No. So delete consumer widget, not consumer. This is widget with and with a with. Great. Now this it will be item dot let's see what he's doing.
Can replace this to do with this line. And of course, this doesn't work right away because we haven't converted this widget to a consumer widget yet. So let's fix this by changing the widget base class to ConsumerWidget and import Flutter Riverpod. And here we should also add a widget ref argument. And now that this code compiles, we can use the products repository directly here instead of the singleton variable. And then we can repeat the same process in the order item list style.
Great.
So let's
we already do that before we work the video.
And import Riverpod. Then we can add a widget ref argument to the build method. And just like we did before, we can copy this line and paste it in here. And then we can use the products repository instead of the singleton. And finally, there is one last widget that we need to update, and that is the product screen widget. So let's also convert this to be a consumer widget and import Flutter Riverpod. And we can also add the widget ref argument to the build method. And then we can copy this line from the previous file and paste it in here. And finally, replace the singleton with this variable, like this. And now that we made all these changes, we can make sure that we save all the files that we have changed. And finally, we can get back to our fake product repository. And I should point out that we no longer need this to be a singleton, because we are only ever going to access this repository using this provider. As a result, we can remove both the singleton declaration and the private constructor as well. And then inside the provider, we can just return a new instance of fake products repository, like this. Then we can save and hot restart. And at this stage, we should be able to see that everything still works in our application. Okay, so up to this point, we had learned how to create a provider. And if we get back to our product screen, we can see that in order to access this provider, we need to subclass from ConsumerWidget. And as a result, in the build method, we get an extra ref argument that we can use to watch our provider. And one important thing that I should point out is that when we call ref.watch, then our widget will rebuild if the value of the underlying provider is updated. And in this specific case, we have nothing to worry about because this provider gives us a repository that is only created once and never changes after that. But as we will see shortly, there are some cases where we call ref.watch to read some data that changes over time. And in this scenario, we want to only rebuild the widgets that depend on our provider. For example, over here, we are getting this product from the repository, and depending on whether it's null or not, then we return this widget or this widget. But the parent scaffold and home app bar themselves do not depend on this.
This is on the product screen. Let's go to here. the better way is to search. I know that. Not this one. Product list. So here we don't need to make it not nullable because we already have a condition for what if it's null. And what he's saying, if this product change, we only want to rebuild the widgets that depend on our product, depend on our provider. And these do not depend on the provider. For example, this is not the best performance because if, let's say, the product repository doesn't change, the list of product assuming is the same, but this specific product may be changed, and then we will rebuild the whole thing. But some widget, for example, the home bar, actually doesn't need to rebuild. But because we already have the const, that means even if we call the build function again, I don't think it causes any issues. But let's continue watching.
And for this reason, we can wrap this code with a consumer widget. And as we can see, this takes a builder argument, which is a function that gives us a build context, a widget ref, and an optional child widget. So let's use this builder and specify these three arguments, and then we can open some square brackets. And then we can pull this entire block of code inside it, and we can return this as a widget, like this. And then what we are going to do next is to take these two lines that we had at the top of the build method, and we can also move them inside the builder, like this. And as a result of making these changes, then only this builder will be called again if the value returned by this provider changes. And that's because here we are using the ref that comes from the builder itself, and not the one in the build method. And this also means that we can convert the parent widget back to a stateless widget and remove this ref argument from the build method. So in essence, ConsumerWidget and consumer give us two ways of doing the same thing. And the difference is that with ConsumerWidget, everything in the build method will rebuild if the provider value is updated. Whereas with consumer, we get more fine-grained control about what widget we rebuild at the expense of more boilerplate code. And in this specific case, there is no practical difference because we only create the products repository once and it never changes after that. But in the coming lessons, we will modify this code so that we can read some asynchronous data that can change over time.
Okay. So I hope you understand what he's talking about. We basically change this back and remove this, right? And the importance is to understand why we are doing so. We wrap with builder, and this time the builder will be a consumer. So, and this one has 3 arguments. I'm not sure what's the last one. And anyway, we will go there soon. Oh yeah, I have. So also it also can take a widget. Okay, never use it. So everything stays the same. So get some water. So we talk about the difference on consumer and consumer widget. In this specific case, there isn't much difference to in terms of performance, but this is a fun, the better way basically. And if we want to extract this widget into a separate widget, then we don't have to get into all the thing, or if we want to add a lot of other stuff in app bar or other thing scaffold. We don't have to rebuild the whole thing again if our product changed. That's what he means.
And in that scenario, it will be worthwhile to use consumer for performance reasons. And by the way, since we have just refactored a few files, you can find an updated code snapshot in the resources for this lesson. Okay, so let's continue in the next lesson, where we are going to start digging deeper.
Dig deeper.
Now that we have seen how to use ConsumerWidget and consumer in our widgets, we are ready to learn about StreamProvider and AsyncData, which are two very useful classes for dealing with asynchronous data with Riverpod. And if we go back to our fake products repository, we can remember that in the last section we have added some future and stream-based APIs to our repository, because these are the kind of APIs that we would like to use if we were connecting to a real backend or a REST API. And we said that in Flutter, we can use Future Builder and Stream Builder to map asynchronous data to our UI. But the Future Builder and Stream Builder widgets force you to work with Snapshot, which requires a lot of conditional code to get the job done. And in this article, I've already mentioned that Riverpod offers a much better alternative. So let's go back to our project and see how we can work with asynchronous data using Riverpod. And one important thing that we need to understand is that whenever we want to read data from a future or a stream, we should declare either a future provider or a stream provider. And we should declare one provider for each of the methods that we use. For example, if we want to read data from this method that gives us a stream of products, then we can go to the bottom over here, and then we can start typing stream, and we can select stream provider from this list of options. And then we can call this products list stream provider and use list of type.
Okay, let's do it. So yeah, I didn't delete all the old code because I like to keep a reference. So what he means when we have a method to get data from stream or future, and we will create a provider for it. And there's a shortcut. Remember we added the snippet okay, it should be stream. I never used this StreamProvider. Go down. Look at that. We don't even need to type the final. And this one inside will be a list of products. And the provider name will be product list stream provider, and I believe we are returning this one.
Product as the type annotation, because this is the type of string that is returned by this method. Then we can remove this async star keyword because we are not using a stream generator. And then inside the provider body, we can type final products repository equals ref.watch. And we can pass products repository provider as an argument. And finally, we can return products repository.watch products list. And as you can see, we have just done something interesting, because in this line, we have retrieved the products repository by watching the products repository provider that we have declared over here. And then we have used it to return the stream that is returned by this method. And this syntax should already look familiar, because what we are doing is to use this ref object to watch a certain provider. And this is exactly the same syntax that we have used in our widgets. And this means that whether we are inside a widget or inside a provider, we can always access other providers as long as we have a ref object.
So we deleted the list because we are not generating the stream value. We're not creating a stream, basically. That's my understanding. Final product equals ref dot watch repository provider. And what we are return, we return this repository y dot watch product list. So this one refers to here. Is it clear? So the product repository, we get the value of. So it's like previous instance for this class. Now we have a provider to get this instance, and then we call this function dot watch. And he was saying with the provider, you see, with the ref, and all these are out of the class. The class finish here, so these are global variable. And with the ref, this is a StreamProvider ref. This is provider ref, but they can all refer to other provider, which is very good.
Now that we have this, we can get back to our products grid widget. And here, rather than watching the products repository provider directly, we should watch the products list stream provider that we have just created. And if we hover over this variable, we can find out that its type is now a sync value of lit.
He said rather than watch the whole repository provider, do you understand? I think I understand. So let's remove the, basically we are mimicking to the way to get the data asynchronously, although it's so this one dot watch we should pass by the we were using this one and to call get to call the get product list, and usually these should be gone. At least this should be gone, because there in reality we don't have a constant value of the product. We can only use this into the testing. In real life, we use this one, and here is in product grid. We should call this. I think we don't have this. AsyncValue. This already is AsyncValue. Then contains a list of products. I think I kind of know what's going.
Of product.
What's the next?
So let's rename this to product list value, and then we need to figure out how to use this async value. So let's delete this line, and instead we can type return product list value dot when, and then we can select this method from the list of options. And as you can see, this method gives us 3 arguments called data, error, and loading. And if we hover over these arguments, we discover that they are actually functions that we need to use to return a widget. So let's implement them. And inside this data callback, we get an argument, which is our list of products. And since this is a callback, we can use the arrow operator. And the return code should be this whole chunk of code that we used to return before. So
look at the code palette. It gives me all the code. So I guess we can take a break then, because dot when, because this one is async value, and we say when data, when we have a data, we return build data grid. That's cool. and when the loading, we have a loading. And here is a, it's not defined, so what should we do? It was here, and we can just extract method. Yeah, the method will be build product grid. Is it correct? Yeah, build the products grid with this one. And you see it's not very smart because we're missing the products. Now we get it. The product is not a tab, so we have to import a list of products. Okay. And we don't need, so when it's empty, here maybe we should also say list section instead of just return the build grid. And if we don't have the product, I see when data unloading and error, layout grid, where is this one used? Oh, here. I guess I'm just, so why it says it's all right. It's not just missing this, but we are missing the, it's two parameter, right? So we need to pass on the product. That's a whole code. Someone's messaging me.
Cut all these lines from here and return them in here. And then we need to return widgets for the error and loading states. So as far as the error goes, we get a callback that gives us an error and a stack trace. And we can use this to return an error message widget, which is one of the common widgets that are included in the starter project. And this widget takes an argument that we can use to represent the error message. So we can type e.toString, for example. And it's also a good idea to wrap this with a center widget, like this. And finally, we have this loading case, which is a callback with no arguments, and we can just use this to return a circular progress indicator. And we should also wrap this inside the center widget, like this.
So in our case, we have our own error widget, not this one. But this one is not that bad. They even give us .car hold it. So we have our error widget, error message widget, which already created, and this one we have, I think the, you see, but there isn't, it's not error and pass error. It should be, oh yes, it's a thing. Should we get the theme? The theme here is quite good. If we don't pass this, I guess it will be something like just default.
Okay, so let me just explain this code that we just added. And the most important thing to understand is that when we call ref.watch on a StreamProvider, then our widget will rebuild every time the stream emits a new value. And this is very important, so let me say it again. Whenever we watch a StreamProvider, our widget will rebuild every time the stream emits a new value. And because streams emit asynchronous data, then we must handle 3 different cases called data, error, and loading. And Riverpod gives us a convenient AsyncValue type that makes it easy to map these 3 cases to different widgets. And it does so in a compiled safe way, making it impossible to forget the loading and error states. And if you have worked with StreamBuilder or FutureProvider before, you should appreciate how much nicer it is to work with this syntax. However, let me stress out that AsyncValue is just a value and not some kind of listenable object. And the thing that really takes care of rebuilding our widget is this call to ref.watch with the StreamProvider as an argument. And by the way, what we just said about StreamProvider works exactly in the same way if we use a FutureProvider instead. And as a proof of this, we could get back to our repository, and if we want, over here, we can copy this entire provider and paste it in here. And then we can rename this provider to product list FutureProvider and replace this with FutureProvider. And because this is a FutureProvider, then we can no longer use this method to return a value, because this returns a string. And instead, we should return products repository.fetchProductsList, which returns a future instead, like this. And now that we have this FutureProvider, we can save the file and get back to our products grid. And if we want, here we can swap this provider for products list FutureProvider. And everything else will work exactly in the same way, because we still get an async value when we watch this. And this is quite nice, because all we have to do is to call AsyncValue.when to handle the data, error, and loading cases. And once again, if this is the first time that you use Riverpod, this syntax may look a bit unfamiliar, but trust me when I say that you get used to it pretty quickly. Okay, so let's continue on the next lesson, where we will test all this new code.
Okay. So basically, he was saying we can change this to FutureProvider. If we get data as a future value, everything is the same.
Now that we have learned how to work with asynchronous data in our widgets, it's a good time to test our app and check that everything still works. So if we hot restart at this stage, we can see that all the products are still visible, and we don't really have any way of testing the loading and error states. And the reason for that is that if we go back to our repository, we can see that the future that is returned by this method returns a value immediately. And this means that as soon as we watch the corresponding FutureProvider in our widget, then the data callback is executed, and we return the list of products. So how can we test the loading and error states? Well, since this is a fake repository, we have full control.
Okay, so let's go to the fake repository. So the end of last session, he added a FutureProvider, which is very similar. Fetch. So products grid. What we mean is we are using the FutureProvider here, and everything is the same, and we want to test the loading and error. I think we will add something here.
What is returned by these methods? So if we wanted, here we could modify this method and add an artificial delay for testing purposes. And in Dart, we can do this by marking this method as async, and then inside the body, we can add a delay of 2 seconds using the future.delayed API. And now that we have this, we can auto restart. And as you can see, we get a circular progress indicator for 2 seconds before the list of products appears. And if you're not entirely sure why this happens, keep in mind that when we call ref.watch, our widget will rebuild every time there is a new value. But of course, the build method needs to return a widget as soon as it is called. And if we call ref.watch on a future provider and the feature hasn't completed yet, then we'll get an async value with a state of loading. And as we know, in this case, we return a circular progress indicator. And then as soon as the feature completes, then our widget rebuilds and we get a data value that we can use to show our UI. And if we wanted, we could test the error state as well by going to the repository. And here, rather than returning a feature, we could throw an exception with a message of connection failed, for example. And if we hot restart now, then we get the loading indicator for 2 seconds, and then we get an unhandled exception breakpoint. And if we resume the execution, we can see that this is now shown in the UI. And this proves that we have implemented all these 3 cases correctly in our widget. And now that we understand how this works, we can remove this exception. And by the way, if we wanted to add a delay even inside this method that returns a string, we could try to copy this line from here and then paste it in here. But this is not valid code because this is not an async method. And the way to fix this is to convert this to a string generator by using the async star syntax. And then inside the method, rather than returning string.value, we could yield our product variable instead, like this. And then we could save and get back to our widget. And here we can try to watch the product list StreamProvider instead. And if we
missed
like this, and then we could save and get back to is to convert this to a string generator by using the async star syntax. And then
okay, so if we want to use to test the work method, and what we will do is to get asynchronous with this star. And again, we will copy this line of code. No, here. And yield, because in the string we don't return, right? So we don't use this one.
inside the method, rather than returning string.value, we could yield our product variable instead, like this. And then we could save and get back to our widget. And here we can try to watch the product list StreamProvider instead. And if we hot reload again, we can see that we get a loading indicator followed by the grid of products. And this confirms that our asynchronous code works for both providers. And since we'll be doing some more testing with this stream, we can keep this delay in here to make sure that we always see a circular progress indicator when we subscribe to this stream. And as we can see, the fact that we decided to implement this fake products repository rather than connecting to a real data source has some advantages. Because when it comes to testing, it is really easy to modify these methods and add some delays or throw exceptions. And all of this will come handy later on. Okay, so let's continue on the next lesson.
We almost finished this module. Let me see how much left. Oh, yeah, we are going number 8, family modifier. Are you still there? It's a very long one.
In this lesson, we're going to talk about family, which is a very useful modifier that lets you pass an argument at runtime when using a provider. So let me start off by showing you an example where we are going to need this modifier. So as a first step, we can open the product screen file where we can find this widget. And as you can see, inside the build method, we have this consumer where we get our repository and use it to get a specific product by ID. And from a UI point of view, this product ID is passed as an argument when we create the product screen widget so that we can show the correct product information when we select an item from this list. And from a data point of view, we can click to reveal the definition of this method. and we can see that this ID is passed as an argument so that we can get the corresponding product from this list. However, our intention is not to use this synchronous method called getProduct, but instead we want to use this watchProduct method that returns a stream. And as we have seen in the previous lessons, whenever we want to use a stream, we should create a StreamProvider that we can then watch inside our widget. So let's try to create a StreamProvider for this method. And if we scroll to the bottom, over here we can add a final product provider equal to StreamProvider, and we can pass a nullable product as the type. And then inside the body of the provider, we can get our products repository like we had done before by calling ref.watch with products repository provider. And then we can return products repository.watch product. And as we can see, we now have a problem because this method takes an ID, but inside the provider we don't have access to it. And in this kind of scenario, we can add the family modifier right after the StreamProvider. And this will let us add an argument to our provider. And the way this works is that we need to specify the type of our argument. So in this case, it will be a string. And then we need to add a second argument after the ref object. And we can simply call this ID. And now we can pass this ID to this method, like this. And now that we have done this, we can get back to the product screen so that we can use our new provider. And done this, we can...
So what he means is, you remember, at this level, we are getting product, and this should also from a StreamProvider. So instead of using this getProduct list, we should remove all these, by the way. I think this is no longer used. See? And we should remove this too. And we will see some error, which is good. And so instead of getting the product in this way, why I have this one? Async. Yeah, we don't need this one anymore. So we create a new provider called StreamProvider. So StreamProvider family. So that's good. So let me try it. See, you automatically having this family. The name will be product provider. The family means we are passing one more parameter than the product, and so it's nullable. So we need a product and a string value, which is the product ID, right? And then we can return so we have a repository, and then return to this product repository dot watch. Yeah, we don't need to write this again. We can. Let me see. Yeah, we are not generating a string, and we actually are on the watch product. At least 𝒂𝒑𝒑𝒂𝒂𝒂𝒂𝒂 automatically give us a code, but actually we already have this, so we don't need to write it again. So, and there is error anyway. So because we are getting the product. See, they give us wrong code. That's why developers are still needed. Okay.
back to the product screen so that we can use our new provider. And inside this consumer, we can now remove these two lines, and instead we can type final product value equal to ref.watch with product provider as an argument. And as we can see, we get an error reminding us that we are using a StreamProvider family, and this means that we need to open parentheses inside here and pass the product ID as an argument. And if we hover over this variable, we can see that we now get an async value with a nullable product, which is what we want. So the next step is to return product value dot when, and then we need to implement these three callbacks like we had done before. So let's do that. And in this case, the data callback gives us.
So when we get each product, we are not get a product from the list because I removed this method. So we use ref.watch for our product provider and the family. So we have product ID, and this one no longer the repository, right? So we also remove this line, and this is the product value. I hope it's clear. We are not getting inside the StreamWidget. We are not getting the whole list of products and then call this function, because this function could be a sequence. So we use this, and then we return .when data great, and error. And loading. Right, giving me so many errors. Yeah. Loading. Huh? What? I'm confused with so many. So .when will be here, and then on consumer you will have this and this, and when you have two more, one, count, two. Scaffold, I don't know how it's all messed up. So maybe we are missing. Okay, still wrong. So scaffold. Why is changing to all this? And then who changed this? Child is the consumer. This is body. I don't know what's going on. Okay. And so then, you know, we just return product value dot win, right? So when data, we have the product, return to this, and when error we do this, loading we do this. I guess. Oh, that's for center. So, and that's the end of the win for this one. And why it can't, if the IDE is so smart, just to tell me what to return, why you can't make all the parameter stuff by yourself? Finally, still expect what I already gave here. Why we still need another one? My goodness. Okay, this is for here, and the green one is for consumer. So consumer does not need to be okay. And then scaffold has this, and then build method has this, and finally, my gosh.
A product that we can use to return all this code. So we can cut all of this from here and we can paste it in here. And then we need to specify the error and loading states. And for this we can reuse the same code that we had in the products grid. So let's go over here and copy these two lines, and then we can get back here and paste them like this. And we also need to import.
And we are using our own error message. Error message widget, and we don't have a message like this.
Our error message widget like this. And now that we've added this, we can hot restart and test our code. So as you can see, here we get the products grid. And if we select any of these products, then the product screen will open and we get a circular progress indicator for 2 seconds before the product.
Yeah, we get error because we didn't fix here. I guess we have to change all these again. Let me see if there's a better way of doing so.
And the reason for that is that in the fake products repository, we have added this delay in the watch products list method, which in turn is called by the watch product method. And this means that whenever we watch the StreamProvider that returns this method, then we also get a delay. In summary, whenever you need to pass an argument to a provider, and this argument is a value that can change at runtime, such as this product ID, then you can add the family modifier, like we have done in this example. And then in your widget, you need to watch this provider by passing the argument that you wanted. And in this case, what we needed to pass was just a string. However, when you work with family, you can pass any argument that you want, including other built-in types, such as int, double, or bool, as well as custom classes that you create, as long as you implement the hash code and equality operators. And the reason that you need to do this is that Riverpod will use them to determine if two values are the same or they are different. In fact, creating a provider with a family, like we have done in this case, is essentially the same as declaring a map of providers, where the keys are strings and the values are providers. And all Riverpod does is to give you a convenient syntax for creating a family of providers that can be indexed by passing an extra argument. And as you work in your own apps, you may wonder when you should use the family modifier. And the most common use cases I can think of are the one that we have just covered, where we pass a runtime argument, such as a product ID, to a widget when we navigate to a detailed page and we want to fetch some data using that ID. And another similar use case is included in the Riverpod documentation, which presents this example where we have a FutureProvider that takes an ID argument, and this is used to create a URL to a network resource that we can fetch using the DIO client. And by the way, if you find yourself creating complex types or passing lists and maps to a family argument, then chances are that you may be doing it wrong, and there may be a simpler way of designing your providers. In any case, we'll see more examples of family as we make progress, so you get a better feeling for when to use it. Okay, so let's continue on the next lesson. In this lesson, we are going to look at another important Riverpod modifier known as autoDispose. And if we open the autoDispose page in the Riverpod documentation, we can read that a common use case is to destroy the state of a provider when it is no longer used. And it also tells us that this is advisable when using Firebase to close the connection and avoid unnecessary cost, or to reset the state when the user leaves a screen and re-enters it. So let's get back to our project and see if we should use autoDispose in our providers. And the question we need to ask ourselves is which of these providers should be disposed when we no longer use them. And a good way of finding this out is by adding some breakpoints or some print statements inside these providers to figure out when they are created. For example, inside the products list StreamProvider, we could add a debug print statement with a message that says created products list StreamProvider. And in order to use debug print, we need to import foundation.dart. And then inside our product provider, we can add another debug print that says created product provider with StreamProvider. We could add a debug print statement with a message that says created product list StreamProvider.
So here, we make it smaller. So that's a fig repository class where we created all these, and in the product list provider, because we're testing, and we can add a debug print. Debug Anyway, we say created product StreamProvider.
And in order to use the debug print, we need to import foundation.dart. And then inside our product provider, we can add another debug print that says created product provider with ID, and we can pass this ID using string interpolation.
Okay. Let's do it. Created product provider with ID. Oh, cool.
And we can open the debug console and restart our application. And as we can see, as soon as the application is loaded, we get this log on the console. Because this page needs to read the data from this provider in order to show the list of products. And then we can try to select the first product. And as soon as we do that, we can see this other console log with the ID of the first product. And the next question that we need to ask...
Debug print. Here. Why is not printing anything? Okay, let's try again. Okay, but we don't have the first one. Is because we didn't use this. We were using the this is very confusing. We were using the future one. That's why we changed. Because we don't even know exactly which API we are going to use. Now you see. Okay.
Results is what happens when we delete this page by pressing the back button. And as we can see, we get back to the products list. But is this provider still active or has it been disposed? Well, one easy way to find out is to open the same page again. And as we can see, this time we don't get a loading spinner and we don't get a console log either. And this should give us a hint that in fact this provider is still active and listening to the stream. However, if we go
Let's do it. Okay. Very good. Now, if we go back, you click here again, we don't see loading and product information, which I think is good. We don't have to, if it has catch, okay. If it has catch, which is a good thing, we don't have to reload again. But this module is about auto-disposal. So we can dispose this provider, and every time when we go to a page, we want to fetch the page again. That's my understanding.
Once again, and we choose a different product, then this time we get a loading spinner and a new console log. And if we continue doing this and keep selecting different products, then we can see that our console log fills up with new lines. And this means that even though we are only showing a single page at a time, we have multiple active providers that are listening to different streams. And this is a problem, because if you are connected to a database such as Cloud Firestore, it will cost us money to have multiple active streams that are not in use. And the solution to this is that we should dispose our providers as soon as we no longer need them. And Riverpod gives us a very easy way to do that, and that is to use the autoDispose modifier. And we should use it especially when working with StreamProvider and FutureProvider. So let's add it to all these providers, like this. And as you can see, autoDispose can be combined together with the family modifier if
on here for all the providers for stream or we all want to add this auto-dispose. What's this? No. Did I press anything? What is this? No? My goodness. I have no idea where this coming from. I was just going to add a okay, everything. Okay, I don't know what's this coming from. What did I press to get rid of that? That's so much struggling. Oh man. What's this? Step over. Is this something to do with debug print? Can anyone help me? Let me just restart the whole thing, maybe. So we are adding a debug print here, and then here we add another debug print. My boss told me don't add debug print, add print, man. Because he said, oh, having too much print is not good. We want to IDE to show we have if you have a debug print, the IDE will not complain. And he said, oh, we want the IDE to complain, so that we know when to delete all the prints. I'm like, okay, fine. So now I think that's whatever I'm doing is wrong. Dot autoDispose. Dot autoDispose. So if we do this, StreamProvider. Okay, that's why. StreamProvider dot why it shows this.
And now that we have this, we can hot restart our app once again. And now when we open the product page, we can see that the corresponding provider is created. And what is really interesting is what happens when we leave the page and come back to it. And as you can see, we now get a little badge telling us that the provider was created again. And we are also going to see the loading spinner every time we get back to this page. And this means that Riverpod is smart enough to dispose this provider and close the connection to the stream when we navigate back and the product screen widget is unmounted. And as a proof of this, we could also try to print a console log when the provider is disposed. And the way to do that is to type ref dot, and if we scroll down this list of options, we see a number of provider lifecycle methods that we can use, such as onAddListener, onCancel, onDispose, and many others. So let's implement the onDispose callback, and inside it we can use the arrow operator, and inside it we can add a debug print that says disposed product provider. And then we can hot rest.
So in here, what he says is to ref dot dispose debug, and we don't need this. Debug put this pose provider. This time we don't need the ID. We can have the ID. Let's try it in this way. We see our uploading, and we go to list. We get error. I think the API changed, that's why. What's going on? No, we can't go to the page, or the app gets stuck. This level is correct. Once we navigate into a different one, we get error. We can't go there because we have error. He doesn't have error.
One more time.
This is autoDispose. Let's see if he added any notes about the potential issue. So, advanced data caching options. Add list. Auto, get to make sure everything is the same. Dot family. StreamProvider dot autopro dot family. Here, I actually have code where we are debugging for all the, not only on dispose. You see, if you see, we have dispose on resume, on cancel, on dispose, caching with timeout. Dot keep live can be used to delay disposal of provider. It can be used to combine nation with a timer to implement catch with timeout policy. Product provider dot auto dispose family. Alive when it's no longer used. Interesting. Then you start a provider. You say, okay, close after 10 seconds. Make sure the timer is also cancelled when the provider state. I understand. It's just I'm just thinking the autoDispose. Why we want to dispose that?
And now we can verify that every time we push a product page, then the corresponding provider is created, and when we go back, the corresponding provider is disposed.
So he said because we use autoDispose every time we dispose the provider, and when we navigate to the new page, we create again.
And once again, this all happens because we added the autoDispose modifier. And before we continue, I want to mention that Riverpod 2.0 is introducing some advanced data caching options that we can use to optimize our providers. In fact, one thing that I want to point out is that while autoDispose will take care of disposing the state of our provider and closing the stream connection automatically, this may not always be what we want. Because if this stream connection is closed when we navigate back, and then we open the product page once again, then we need to load the data from the stream again. And if you are connected to a remote database and we pay for data reads, then this is not ideal. So it would be good if we could implement some form of data caching, or at least tell Riverpod to not dispose the provider's state.
A new stream connection is made every time we open the product page. Yes, not ideal if we pay for data reads from a remote database. Some form of data capture would help.
Immediately, and instead to do it after a certain delay. And in order to help us with that, the new Riverpod 2.0 API has introduced a new method called 𝒂𝒑𝒑𝒂𝒂𝒂𝒂𝒂𝒂 that we can use to hold on to the state of the provider even when it's no longer needed. And we can use this to enable data caching using a timeout. So let me show you how this works. And the main idea here is that inside a provider that has the auto...
A phone call. Hello? Okay, let's continue.
Post modifier, we can call ref.keepAlive, and this will preserve the state of our provider. And to show you that this works, I can hot restart the app. And as soon as I go to the product page, then this console log will appear. And the interesting thing is that as soon as we leave the page, then we don't get another console log telling us that the provider...
So thanks to the 𝒂𝒑𝒑𝒂𝒂𝒂𝒂 the provider state is no longer disposed when we leave the product page. Okay.
Page, then this console log will appear. And the interesting thing is that as soon as we leave the page, then we don't get another console log telling us that the provider has been disposed. And this proves that the provider is still holding on to the state. And in fact, if we open this page again, then we don't get a new fetch request. And
I have to reload the whole thing.
in this lesson, we're going to look at another important providers. In fact, one thing that I want to point out is the new Riverpod 2.0 API has introduced a new method called 𝒂𝒑𝒂𝒂𝒂𝒂𝒂𝒂 that we can use again, and we don't get a new fetch request. And just to be clear, using 𝒂𝒑𝒂𝒂𝒂𝒂𝒂 by itself is not very useful. And what we may want to do instead is to add a timeout so that we can dispose the provider after a certain delay. And this is a common data caching approach that is used by many apps. And the way we do this is to assign the result of this expression to a final link variable.
Look here.
And as we can see, this is a variable of type 𝒂𝒑𝒂𝒂𝒂𝒂𝒂. And once we have this, what we can do is to create a timer object with a duration of 10 seconds, for example. And then we need to specify a callback. And inside the callback of this timer, we can call link.close, like this. And this will be used to dispose our provider after the given delay. So if we want to test this out, we can hot restart the app once again. And then we can open the product page, which triggers the console log. And then we can leave the page. And if we wait for 10 seconds, we can see that the provider has been disposed. So this is just a little preview of the data caching capabilities of Riverpod, which are especially useful when we have a list of items that we want to cache for a certain period so that we don't make too many calls to fetch the data from the network. And we will revisit these caching APIs in section 12, where we will implement the product search feature. But for the time being, we don't really need to worry about these advanced data caching options, and we can stick to the default behavior of autoDispose and remove these arguments. And we can also remove all these print statements, like this. And then we can do a summary of what we have learned. So the bottom line of this lesson is that whenever you work with StreamProvider, it is probably a good idea to use autoDispose by default, because this will ensure that we close the connection to the string when we no longer need it. And in general, the same applies to FutureProvider as well. And you may be wondering how this all works under the hood. And the answer is that whenever we watch a provider inside a widget, Riverpod will add that widget as a listener to that provider, so that it can rebuild it if the value changes. On the other hand, when the widget is unmounted, for example when we navigate back, then Riverpod will remove it as a listener. And when the last listener has been removed, then the provider itself is disposed if we had used the autoDispose modifier. In fact, using autoDispose gives us the same default behavior that...
So how it works under the hood? When we watch a provider inside a widget, the widget is added as a listener, so that it rebuilds if the provider value change. When a widget is unmounted, for example, on back navigation, the listener is removed. When the last listener is removed, the provider is disposed if we are using autoDispose. Is it clear? Honestly, not very clear for me, because first we get a bug, and I don't know why suddenly it comes like this. Let me take a screenshot and let's see, ask ChatGPT what's going on. I already have a lot of screenshots. What is okay, this is a Flutter project with Riverpod. What is this error coming from? Why is there a yellow arrow? On the screen. Okay, and see what he said. Next to product declared in your provider indicate a warning. Check the warning. Hover over the yellow arrow to check. Wait. Yeah, continue to do next page, Lord. We didn't say anything special. We probably need to read the document, because it doesn't show anything. has been assigned during the initialization. Product. Your I just get started. I get a bug land. Can you wait?
Just wait and just see now.
No, you go to the next pages.
And I'm on my first one.
Yeah, go to next page. I will help you with all the homework together. My daughter, we are recording, Lulia. My daughter is here. She wants me to help her homework. I already helped. I just get stuck again, as always, and I have no idea what's going on. I don't know where this yellow error suddenly popping up. Let me close everything. Okay. Let's start. Now you know how much struggling I have each day of all doing this yourself, and I'm not good at it either. See, what is this? See, now it shows all okay. And let's run the app again. Let me ask, how come the yellow arrow appeared? Did I accidentally press anything? Warning in your code. Code warning, okay. Probably. Okay, fine. Let's read. Oh, yes, several languages. Wow, that's amazing. Do you think he can? Can you? The website changed a lot. It is truly amazing. Docs. By the way, let's see if it's running. It's running, but I think we will get an error. Why I have two? So the first one didn't close. Yeah. I think it runs okay, but the moment we navigate to a specific product page, we will see an error. And you see there's already some sort of warning in the debug console. No, this is not running. It's okay. So let's see. Once we go to a page, it's okay. See, something gets stuck earlier, and it's actually all okay. So what we were saying is, when we navigate into, so first we created this product stream provider, which is here. And then when we navigate into a specific page where we are using the product provider, we say created ID, but we didn't. There isn't on something. Let me comment this part and restart again. And you see, we go to a main page. Interesting. Even though we are restart, we directly go to this product page. So I believe because we have auto pause, so if we go back, it said cancelled and disposed product provider, and so this is the home page. Let's do again. So if I say go to that page, they say okay, created a new ID, and I go back and cancelled and disposed, and I click this again, and we created product ID again, and then we go back, disposed. The reason is we have this auto dispose, and if you remove that, hot restart, now let's see the first product. You see we created product with ID 1. When we go back, we only have the cancelled provider, but we don't have undispose, and we don't have resume. And we go here again. Now we resume. Okay. So this one is to we did not create a new one, but resume the existing one. Go back, cancel, resume, cancel, cool. And when we click the number 2, now you create a new provider with ID. So my question is, I think this is good. So why would we use auto dispose and then you keep alive and set a timer to close? Now if you add back, auto dispose means we disposed, and there isn't resume. We just cancel and dispose each time. At least we get rid of that warning where we have no idea where it come from. Let's finish the lesson first.
When we use StreamBuilder and FutureProvider, because these are widgets that create a stream subscription under the hood and cancel that subscription when all the listeners are removed. However, when we use Riverpod, we have various options to configure the way providers are disposed. And if you remember, when I first introduced the Riverpod package, I told you that it is a reactive caching and data binding framework. And in fact, we had just started digging deeper and discovered that providers have their own lifecycle methods, just like widgets do. And if we want, we can use these methods to fine-tune the behavior of our providers. But in the majority of cases, we don't need fine-grained control, and we just need to remember to use autoDispose when appropriate. In fact, when is it a good idea to use autoDispose? Well, if you have a StreamProvider, chances are that you always want to use autoDispose, because this will ensure that your stream connection is closed when you no longer need it. And a good example of this is when we have a detail page that we can use to view different products, like in this example. So once again, I recommend that you use autoDispose by default, both with StreamProvider and FutureProvider. But just keep in mind that data caching is a complex topic, and in certain cases, you may want to cache the data on the client for a certain amount of time before reading it again from the server. But for now, I just wanted to show you what APIs are available in Riverpod to deal with this. Okay, so let's continue on the next lesson.
Okay, we almost finished this lesson, so the next one will be create a reusable. Yeah, we have the last two, and then we finished this lesson. That's a lot. But he said we should always use autoDispose whenever we have a StreamProvider or a FutureProvider. Yeah, we should get the time to read all these. Where is autoDispose? Okay, get started. The glass always dropping, so yeah, this is very good. One reason when using Firebase to close the connection while unless it's closed, right? To reset the state when user leave the screen and re-enter it. Riverpod. Why that may be outdated. It will be updated in the future, but for now you may want to refer to the content in the top of the slider bar instead. I'm tired. I just want to finish this lesson and let's continue.
In this lesson, we're going to introduce a new reusable widget that will help us whenever we need to work with AsyncValue. And as we have seen in the products grid widget, whenever we have an AsyncValue and we need to return a widget inside a build method, then we can use the when method and specify the data, error, and loading callbacks. And as we will see, there will be many pages where we need to work with AsyncValue. And while the data type that we need to use is likely to change every time, we probably want to show the same UI for the loading and error states. In fact, these two lines are exactly the same here as they are on the product screen widget over here. And we don't really want to copy paste them every time we create a new widget that uses AsyncValue, because this is likely to lead to problems later on. For example, in the future, we may decide to use a different loading indicator or change the appearance of the error widget. And if we have copy-pasted this code across different widgets, then it becomes really difficult to update it everywhere. And in this kind of scenario, we should create a reusable widget that takes an async value as an input and handles the loading and error states for us. And by the way, I have written this standalone article that explains how this all works in practice. So let's go ahead and implement this in our project. And what we want to do is to find our common widgets folder, and then inside here we can add a new file and call it AsyncValueWidget.dart. And inside here we can add a new stateless widget, and we can call it AsyncValueT and make it generic on type T, like this. And of course we need to import material.dart. And we only need the class name to use this generic argument, but not the constructor itself. And then we can add a final async value of type T property called value. And in order to use this, we need to import Flutter Riverpod. And then we can add a second property. And this will be a function that takes an argument of type T and returns a widget. And we can call it data. And then we can add these properties as a required argument to our constructor, like this. And then we need...
So we can just copy, oh, it does not have copy paste for this one, and we want to add it into the common widget here. Called AsyncValueWidget.dart, and copy paste this and import material, and this one will be Riverpod, and import the arrow widget. Nice. So
implement the bit method. So over here, rather than returning this container, we can return value.when, and then we need to pass the data, error, and loading arguments. So for the data argument, we can pass data, because this is a function argument that matches the data that we have given as a property. And then we need to add the error and loading states. And we can borrow these from the product screen by copying these two lines, and then we can get back here, and then we can paste them in here. And of course, in order to use the error message widget, we need to import it. And then we can save. So this completes the implementation of our AsyncValueWidget. And just to be clear, what we have just done is to create a reusable widget class that takes an async value as an argument and gives us a default implementation for the error and loading states. And because async value is generic on type T, then our widget as well as this function argument are also generic on type T, so that we can use the data callback like this. So let's see how to use this in practice. And as an example, we can go back to the products grid widget. And then if we scroll up over here, rather than using this syntax, we can delete this. And instead, we can type AsyncValueWidget, passing a list of type product as an argument. And in order to use this, we need to import AsyncValueWidget as well as the product type, like this. And then we need to give it a value argument, and this will be our product list value, like this. And as a result, we can scroll down and remove this error and loading argument, because AsyncValueWidget takes care of them for us. And then we can move over to the product screen widget. And over here we can do the same thing and delete this code, and instead we can return an AsyncValueWidget that we can import. And this time the type is going to be a nullable product, like this. And of course we need to pass in a value, which is our product value, and we can remove the error and loading state as well. And if we hold reload now, we should see that
So why is the list value equals watch the StreamProvider, which is here. Or did we rename? Yeah. And then you change in product screen. I need to take a nap. So sleepy. Yeah. This is the same because we move all these. And change this to here. Now you have value and data. But this time it's just one product. And it's nullable. And here you need to import for the we need the value like this.
Still works as expected. So this is good progress, but we are not done yet because there are two more widgets that are still not using the StreamProvider that we have created. And if we do a project-wide search for products repository provider, we can find out that we had to update this shopping cart.
Okay, we have to finish what's left today. So I was feeling tired and took a short nap, and also my daughter is here. Just some family issue, but we are here, almost finished.
In this lesson, we're going to introduce a new reusable widget that will help us whenever we need to work with
We already
AsyncValue.
did that. So we are doing
and then we need to implement the build method. So over here, rather than returning this container, we can return value.when. So let's do this. So over here we can delete these two lines, and instead we can type final product value.
So wherever we are using this is in the shopping cart item. I can't find so hard shopping. Actually, I should go to find here. Shopping cart item. Okay, great. So
this is good progress, but we are not done yet because the two more widgets that are still not using the StreamProvider that we have created. And if we do a project-wide search for products repository provider,
so if we search for product repository provider, right? It's where we are. We have two places we are using this. We need to change this into something like the product screen, basically, like this. That's what we are doing.
We can find out that we had to update this shopping cart item widget. So let's do this. So over here we can delete these two lines, and instead we can type final product value equal to ref.watch, and inside it we want to watch for the product provider passing item.productID as an argument. So this gives us an async value that we want to use to return a widget, and all we want to do in this case is just to wrap this padding widget with a new widget, which will be an async value widget with a nullable product, and we can import async value widget, and then for the value we can just pass product value like this.
So everything else is pretty much the same. We can grab the whole thing to here, and you can hear my daughter's noise. So I think she's waiting for me to go out. And this product is also nullable, so we also have we need to return this one if we have a product including this. Cut. I'm recording the lesson. 马上就完了。Almost finished.
Also, there's a team called the Blueberries and the Green Pickles. Can I show you the blueberry dance?
Julia, we are on the recording. Look at the time. Okay, I almost finished. Okay, just wait. After this is done, we go out.
Okay.
Not easy. Yeah, not easy. Today, the whole day, we didn't even finish this. We almost finished.
Hey, you, are you saying that
And the second argument is not a child, but instead is a data callback that gives us a product, and we can use this to return a widget. And as you can see, over here we get an error because this product is nullable, but the shopping cart items content widget wants a non-nullable product. However, in this case, it is safe to use the assertion operator on the assumption that this widget will always take an item with a valid product ID. So once again, this is just an assumption that I can guarantee to be true in this specific case. And now that we have updated this widget, we can test our changes by selecting the shopping cart icon. And as you can see, as soon as we do this, we get 3 loading indicators, because this page shows 3 items inside the list, and each one of them now uses a AsyncValueWidget, which will show a loading indicator until we have some data. And I will agree that having multiple loading indicators inside the list view is not great UI. So if you wanted to make this better, you could use the shimmer package, which is great for this kind of scenario. So in this case, rather than using AsyncValueWidget, you could just use productValue.when and provide some custom UI for the loading state using the shimmer package. So feel free to implement this as an exercise if you want. But as far as I'm concerned, I want to stay on track without spending too much time building UIs. And finally, we want to open the order item list tile, where we still read data from the product repository provider, like...
See, we got this error again. There's definitely something wrong. Although the app is still running. Whoa. Type StreamProvider family. Provider stream is not a subtype of author stream. Okay. I need to take a screenshot and figure out why we have this bug. We are following exactly what the video is showing, but we get error. And I'm very sure it's something wrong with this one. We can just remove. And now let's get restart. Product provider. this one first. By the widgets. Inside by the layout. I need to spend the time to go through all the code to figure out what's going on. Now we restart. So this is the shopping cart. This one is okay. You see, I'm in the same screen as him. So each product was loading separately. That's why we see 3 loadings on. No, not implemented. And if we go to product, the error is gone. Yeah.
And instead we want to use our StreamProvider instead. So once again we can delete these 2 lines, and instead we can type final product value equal to ref.watch with product provider passing item.productID as an argument. And once again what we want to do here is to wrap this with an AsyncValueWidget that takes a nullable product argument, and we can add all the required imports as usual, and then we can add a value argument which will be our product value, and replace this child argument with a data callback that gives us a product. And
the easiest way, I think, is to wrap this with a builder, and this is, let me import, and this is not a builder, this is called a data, and we directly get data called product. Lulia, I thought you are going to work code by yourself. And we need a value. I don't want the value to be last. So the value will be product value. And of course the product is nullable. You know, I like to be safer. Just to use this, that's okay. And we import this empty placeholder widget, whatever it is. So everything should work.
in this case we are also going to use the assertion operator over here, and then we can save and hot reload, and we can test this code by opening the orders page. And as soon as we do this, we also get 3 loading indicators until the data is loaded. And once again, this is something that you could improve by using the Shimmer package. And this completes all the changes that I wanted to make. In summary, the main takeaway of this lesson is that by implementing a reusable AsyncValueWidget, we no longer had to worry about the loading and error states when working with AsyncValue. And we will use this class extensively to improve code reuse across the project. But of course, there are some cases where you may want to have some custom loading and error UI, and in those cases, you can just use the regular AsyncValue.when method. Okay, so let's continue on the next lesson.
Okay, we only have a recap. Then we finish this module. This will be we are going to wrap up an exercise. So module 4 will be finished. That's great. I think there isn't much stuff.
We have now reached the end of this first section about Riverpod.
Yay!
And we have covered a lot of ground already, so let me give you a quick summary of the most important concepts that we have learned. And the first thing that we did was to use providers as a form of dependency injection. Specifically, we made some changes so that we no longer need to access our fake products repository as a singleton. But instead, we have used a provider that returns our repository, and we have converted some of our widgets to ConsumerWidget so that they can get a ref object inside the build method that we can use to watch our repository. And as we will see in detail later on, by doing things this way, our code becomes more testable. And because the fake products repository is a dependency that does not change, then we can use a regular provider to make it available. But sometimes we want to read data from a future or a stream-based API, and this data can change over time. And in this case, we should create a future provider or a stream provider, like in this example. And inside the widget, we can watch that provider using exactly the same syntax. And when we do this, we need to keep in mind that our widget will rebuild every time the data changes. And we can use the resulting async value to map the data, error, and loading states to the UI. And we have also seen that we can create a helper AsyncValueWidget that takes care of the error and loading states for us. And we have also learned about the family modifier. And we said that it's very useful whenever you have an ID or an argument that you need to pass to a provider in order to obtain the data that you need. And we have also learned what is the role of the autoDispose modifier in closing any open stream connections by disposing the state of our provider when it is no longer used. So overall, the focus of this section was on how to access dependencies in our widgets by watching the corresponding providers, as well as how to read asynchronous data and dealing with loading and error states. And as we have seen, Riverpod offers a unified API to do this by giving us a ref object that we can use to watch our providers. But in addition to accessing dependencies and reading data, we also need to learn how to manage application state, as well as use our repositories to write data. And this will be the main focus of the next section, where we will dive deeper into state management with Riverpod. But I think it would be already quite valuable for you to try and use Riverpod in your own apps and get some practice working with providers, consumers, and asynchronous data. And before we move on, I'd like to give you an exercise, and that is to grab the starter project that I shared at the beginning of this section and see if you can repeat all the steps that we have covered and understand how everything works. And you can try to do this independently without watching the videos. And you can find some more detailed instructions about this in the notes below this video. Okay, so let's continue on the next section.
Great, thank you. Yay, we complete this module. See, we still have a lot. Module 9, module 10, 11, 12, 13. Good. Okay, great. We will finish all of this. Okay, and so today is a very long video, and you didn't miss that much in the last part. You know, most of the video is reading the slides or changing the code, which you can see me changing as well. And today is not that efficient. I feel like the video is very long because we had quite a few gap. This is already done. And I will need to read more for this package, and they have very good documentation, and I will add into the video description. Yeah, so it's very good, and we did a lot of changes. Let me see what ChatGPT tells us. Add Riverpod deficiency. End of module 4. Great. Thanks so much, and that's it for today. Bye bye. Thank you. And happy learning.